Next one, finding the direction. For example, you have one straight wire or conductor, long straight conductor, having current flow upward within it. Okay, and this current is increasing with time. This is most important thing, increasing with time. If the current flow is steady, nothing going to happen. No induced B, no induced EMF, no induced current produced within the secondary loop, right? But now the I is increasing in time. The magnitude of the I is increasing. Let's say 0.1, 0.2, 0.3 up to 1 ampere. Okay. So now the change is increase in I, original. Okay, surrounding the long straight wire here is B, original. How to determine? Grab's rule or right hand rule number 2. Okay, place your thumb along, okay, the direction of the current upward, grab the wire. So if you grab the wire, you will see that, okay, the B original produced by the long straight wire here, okay, on the right side will be into the pitch. Okay, on left side will be out of the pitch. This is the purple color here is B original. Okay, coming from long straight wire. Right. Then, okay, all of a sudden, during the moment of increasing of I here, increasing with time here, within that instant, okay, must be I induced within the loop. Why is it symbolized by R? The load, the resistance. Okay, so the B original is into the pitch, right? Okay, so within this loop, okay, focus at the center because at the center B is the strongest, the one that effective. So the B induced in the direction that oppose the change. So what kind of change? Increase. The flux is into the pitch, right? So the induced things don't want to change, okay, don't want to change, therefore is going to produce the B which is out of the pitch, right? So if you use Grab's rule at this, let's say, section, okay, to have B which is out of the pitch, okay, you're going to have current flowing up like this, isn't it, at this section? So the current flowing up, this is I induced or IR here, is the same thing with this, right? So flowing like this, flowing like this, flowing like this, this is I induced. At any side, okay, if you use Grab's rule, you will figure out, okay, place your thumb in this direction, look at the center. By using Grab's rule, you will see that the B is out of the pitch, whether this side or this side or this side. So the I induced will flowing in this direction. Why? Because the purpose of the induction not to change, right? So it don't want to, the second loop here don't want to have an increment of flux into the pitch. That is why induced flux or B produced here is out of the pitch, because it don't want to increase amount here because of that. Okay, so now we're going to refer for a permanent bar magnet and a circular loop. Okay, as the magnet move to the right, okay, approaching the circular loop, positive flux increase. The north amount, the strength of the north, the flux or B coming from north pole here will be increased in amount through the coil. So the coil going to experience increment of flux, isn't it? So increment of flux, right? So increment of flux, increases of flux. Okay, so B induced will be in such direction so that it will oppose the change. So it's going to be in this direction. Opposite. So this is B induced. Okay. So let's put your thumb to this section where you can physically or it is exteriorly can be imagined by you. This one, right? Okay. So place your thumb, place your 4 fingers, okay, to this direction. Okay. So your thumb is in this direction, correct? So the current flow is in this direction. This is the direction of I induced within the circular loop, right? So the blue color in figure B here is the B induced. Okay, is the B induced. Okay, to encounter, okay, the increasing of positive flux of this one. Okay, because remember the induced flux, induced B, don't want to change. So you have to check what kind of increment or decrement. If it is increased, normally it will be in opposite direction. How about if it is decreasing? So let's say if you take this permanent bar magnet away from the circular loop, okay, the flux, the positive flux experienced by the circular loop will be decreased, right? When it is decreasing, okay, then the B induced, the flux induced, don't want to change. It will produce B induced or flux induced in the same direction to the original because it don't want to change. So you have to check what kind of changes experienced by the loop first thing first. Okay, so finding the direction again. So let's say you have a electromagnet. Instead of using permanent bar magnet, now we're going to use electromagnet or solenoid. Okay, let's say you have this circuit is closed circuit. Okay, current going to be established, right? Current going to be established, okay, within this loop from positive terminal to the negative terminal. Okay, so by using this section, okay, use Krebs rule, right? So your B, okay, your B will be to the left, right? To the left, okay, to the left. So your B going to be to the left, right? Represented by this, okay, represented by this B original. Alright, so then I induced will be in opposite direction. Okay, because increment, right, from 0 I, now all of a sudden you have some amount of I. So the induced B in such direction opposite to the original because is going to produce another B induced in order to cancel out, right? To cancel out the B original. Okay, so now this is the first thing. If let's say the switch is open, if the switch is open like figure C here, okay, the current flow going to decrease in amount and finally become 0. So the B original experienced by the loop here will be decreasing in amount, right? So the B original is in this direction. This is the B original. The B induced will be in such same direction. This is B induced in the same direction. So that it produce I induced in this direction. Because it is decreasing in amount. The original current is decreasing in amount. So the original B also decreasing in amount. That is why the B induced going to support the situation, because the idea is not to have any change. It want to maintain whatever the previous situation it has. Okay, so from here we are going to determine the direction of I induced, okay, which is upward like this. Okay, now question number 8. Okay, at the back, what is the direction of the current induced in the resistor at the instant the switch is closed? Okay, so if the switch is closed, current going to be established from positive terminal, okay, and then entering negative terminal. So the brown color here is I original, which by using Grab's rule, we're going to determine the B produced by this section. Okay, place your thumb along this, okay, and grab this section. You will get somehow like this. Okay, of B original. So this is B original, right? For the induced B, you don't want to change. Remember, the idea is don't want to change. So what kind of changes are experienced by the induced or loop here? The changes is increasing of I original from 0 to some amount. So increase of I original increase. So the B induced will be in a way that, okay, going to be in a way that oppose the change. So the direction will be in opposite, because you don't want to have increment amount of I original. So in such way, if you are using Grab's rule, please take this section, okay, by using information of the B induced. The purple color is B induced direction. Okay, place your thumb, okay, along this, grabs your four fingers, grabs according to the direction of the purple color. So your I induced will be in this direction. This one I induced. Okay. Alright, then question number 10. Find the direction of the current in the resistor A at the instant the switch is closed. If the switch is closed, stable current going to be established from positive terminal to the negative terminals. Okay, so this is I original. Okay, so by using this section, use Grab's rule, place your thumb along the direction of the I original, grabs it, so you will have B, which is in this direction. So this is B original. Right. So the secondary loop here going to experience changes, right? This one going to experience changes because this one increase in amount. So B original also increase in amount. So the secondary loop going to produce its own B, we call it B induced, in such manner to counter back, not to have the changes. So the changes is increasing. So it's going to produce its own B where the direction must be in opposite to the original because it don't want to change. So this is B induced. By using this information of purple color B induced, grab this section, okay, put your forefinger along the direction of the purple color B or B induced, okay, your thumb will be pointing to this direction. Okay, so this is I induced direction. Right. Madam really hopes that all of this explanation can benefit you all in terms of direction. So please be particular. The most important, you need to check the changes happen, and then the idea of the B induced or I induced actually to have, not to have the change, to oppose the change. Okay, so you check. If let's say this one is decrease in amount, all of a sudden madam going to open this switch, what will happen? The amount of the I will be decreasing, isn't it? Now if the amount of the I will be increasing, the B original also will be decreasing in amount. So B induced will be in the same direction to the B original, because the idea is not to have the change, to oppose the change. Okay,